The next startup is Emanuele Dalla Torre from Israel University, and he will talk about QuantyMize.
So good afternoon, everyone. I would like, first of all, to thank Adi, Yaron, and Ronit for setting up this wonderful conference here at the Cyber Week, this Quantum Day. And I would like you also to thank you for the opportunity to tell you about QuantyMize. And I'm presenting for the first time the company in public. So I would say this is quite an event. And we are the leader in quantum accelerated algorithms. So the startup was born out of discussions with Daniele Porat, the CEO, who is here. And we were discussing about what we found to be the huge irony of quantum today. Of course, when you speak about quantum physics, you want to go beyond like 0 and 1. It's not either 0 or 1. It's something more complicated. It's a superposition. But then we saw that actually the industry was stuck in a binary thinking. What do I mean? Is that people believe that the quantum advantage will come only when you have 1 million qubits, or maybe if you invest in Chaim, it will be 100,000, still a very big number of qubits. And until then, there is actually no advantage that can be found. At QuantyMize, we deliver quantum advantage today. So that's our dream. How we do that? So if you want, think of a metaphor of trying to climb a huge mountain. And there are two ways to do it. You can just stand by and wait until someone will come and build a paved road for you, and then you can very easily go up on your highway. Or, and that's what we do at QuantyMize, you can build your own four-wheel, and somehow, even without a road, you can go up and get to the peak first. So what we need to do in order to get there is, first of all, to find problems that are very complicated to solve. Usually these are the so-called NP-hard problems. These are problems that classical computers have strong difficulties in finding a solution. And they are usually found in problems that involve optimization, especially of combinatorial problems, in which you have many, many options you need to check. So that's point number one. Point number two, because we are in industry, we need to make money. So you need to actually find a problem that is worth a lot of money, so that if you can deliver some improvement, it will translate into a revenue for your company. That's something I learned, from Daniel, coming out of the academia. It's not enough to solve a problem. It actually needs to be a problem that is important. And luckily, in our modern world, we have many of those problems. Think of logistics, think of energies, think of AI. These are all problems that are worth a lot of money and complicated to solve. So next, what we do, we apply what we call the TLA process. So T stands for transform, which means take your real-life problem and translate it to the language of quantum computers. Step number two is to leverage the capabilities of quantum computers. We are a software company, so we can actually offer to our customers the usage of all the hardware available, photonic, superconducting, all the technology we've heard about today. And I would say that until this point, this is quite generic to companies like us, that do software. But the third point, this is the secret sauce, is actually to accelerate, meaning to finding better algorithms, and in particular, better mappings between the real-life problem and the quantum computer, so that if the quantum computer has some advantage, you actually use it to solve your problems more efficiently. So that's the dream, and now I would like to present some results. So this is the landscape of typical optimization problems. So in the x-axis, you have the number of items. So on the left, you have very easy problem. On the right, you have very complex problems. And the y-axis is actually the one that goes between very simple model, so like university models that you have 1, 2 constraints, to real-life problems, in which number of constraints is very, very big. And of course, you would like to be somewhere here in the orange area. Now, if I focus on a specific optimization problem, the so-called knapsack problem, one of the typical optimization problems, I ask myself, I look in the literature and ask myself, what is the size of the problems that have been solved using the available superconducting quantum computers or any quantum computer? What you will see is that all the examples in the literature are, on the opposite regime. So either small or, small in both senses. We at QuantyMize were able to get here to solve a problem on the existing hardware. So on the same hardware as those works, we were able to solve a problem that had hundreds of items and constraints using an algorithm, an accelerated algorithm called ECO, which is proprietary to QuantyMize. ECO stands for Efficient Correlated Optimization. So this is just one example. So how does that translate in practice? I'm going to tell you about 3 projects that we are running for our customers, for our paying customers. The first project, so that you have an idea of which type of problems we can solve, and maybe you can come up with the next problem that we will solve. So the first topic is about risk management. In particular, we find the word of energy as a problem, as a word that is very changing very fast, and where new optimization algorithms are needed. What you see here in this map is just an example. You see this is the map of California, and this is essentially the electric grid, and the color coding stands for the maintenance. So as you can guess, in public infrastructure in the US is sort of problematic. And as you can see, there are a lot of reds and green and orange dots, which means that things that needs to be improved. You would like to improve everything, but you have a finite budget. So you need to select which one of these points you would like to improve. And that's essentially what we do as an optimization problem, finding, for a constrained budget, what are the best interventions that you can make. So the challenge is, of course, you have hundreds of possibilities, hundreds of production facilities, which translate to 2 to the 100 different, which is a huge number, many options that you can select from. So the results that we were able to solve in this case for our customer was actually not to improve the optimization. I mean, they were able to solve the optimization problem well, but we could do it much faster. So instead of taking for each step of the optimization a minute, we could do each step of the optimization within that, fractions of a second. So it's, maybe the same result, but much faster, which allows you to do a much better, much faster loop of the optimization. The application number 2 is still in the world of electric grid, here in the presence of renewable energies. So as you know, the world of energy is transforming from a world that was, there was central production. Now we have distributed production with photovoltaic cells. It's a huge change. And then you need to optimize the way that you manage your photovoltaic cells and also your storage units. So sometimes you produce too much energy. That's actually, you don't think about it, but sometimes this is a problem by itself. So you need to store that energy and then use it later. By the way, I heard that also for the water, there is a similar problem. Sometimes the water comes down too fast, right, like today, and then you can't use it, so maybe you can store it and then release it. So it's the same problem for energy. And in our POC, what we were able to solve is a problem that have hundreds of interconnected units, so of users and photovoltaic cells, storage units, and the results are as follows. First of all, we were able to bring up an improvement of the energy production by photovoltaic cells by up to 20% in our POC. As you all know, from January 1st, 1.5%, right? So that's, okay, 1.5% is a lot, but 20% is much more. So if we can improve the efficiency of the grid by 20%, that's a significant number, very significant number. And also, we were able, with the same algorithms, also to improve the number of cycles that each battery is going. So how many times you need to charge and discharge your battery. And this is very important, by 50%. So I would like to summarize. So I've shown you some examples of what QuantyMize can do and how our POC by our customers are successful. I told you about decisions-making problem in which you need to make decisions under uncertainty. And the quantum algorithm allows you to explore the large decision tree more efficiently. That's the idea of this superposition, of this whole superposition that helps you solving the optimization problem faster. I told you about renewable energies, and for instance, I told you how algorithms can delay the battery burn down, which means that as you all know, the problem with batteries is not actually production, but what we will do once the battery is not more functional. So if you can extend the lifespan of a battery by twice, that's very, very important and will make our world greener. The third problem I didn't tell you about, and the reason is that that's something to do with defense. So I cannot give you all the details. I just want to tell you that it's related to an optimal control of complex devices. And these are the POCs we are currently working on. We are still small, so these are the first 3 projects. And we have more projects that are running right now, or that are, they will occur very soon, in particular related to the connection between AI and quantum. As you've heard, this is probably the next big challenge, how you can combine both AI and quantum together, and we have very nice ideas that we are working on. So I would like to conclude with our main statement, which is that it's not about having 1 million qubits and not about having 100,000 qubits. It's about knowing what to do with the current state of the art, which is around 1,000 qubits. That's really what I believe to be the challenge today. At the QuantyMize, we have very big ideas how to do that. I know there is no time for question, Lev, so I invite you to visit our website where you can learn more. So this is, okay, yeah, I forgot to tell you. I forgot to tell you that this is actually the first time that we are presenting QuantyMize, and the website is under construction, but actually 3, 2, 1. Okay. So we have a brand new website. I invite you to visit the website. You will find the usual stuff, but you will find also something which is very nice. It's actually a chat. And you can ask there the questions, and you can either choose the chat to give you an answer. It will always give you an answer, but you don't know whether it is correct or not. And if you are unsatisfied, then you can, feel free to contact us. So thank you for listening.